Hello, I am Joseph Blakemore, and today I will be teaching you guys about electron configuration and orbital diagrams. So to start off with an introduction, the first thing I want to tell you is, well, what is electron configuration and orbital diagrams? Well, it's nothing more than it explains how orbitals are filled by electrons and in what way they are structured by their levels. So, there are different levels on which an electron can be in depending on what type of atom it is. So for instance, you can bring the camera over here. There are different levels of energy that electrons have. You have your first level, your second level, your third level, your fourth level, fifth level, and your sixth level. There is a seventh level, but for purposes for today, we're only going to talk about the first six levels. Now, in each level, there are different types of orbitals. So for your first level, you have your s orbital. For your second level, you have s orbitals and p orbitals. For your third level, you have s orbitals, p orbitals, and d orbitals. For your fourth level, you have s orbitals, p orbitals, d orbitals, and f orbitals. But we're not going to talk much about the f orbitals, just the s, p, and d orbitals. And so on and so forth. 5 and 6 also contain sp, d, and f. Now, before I begin with explaining how exactly to do electron configuration and orbital diagrams, I should first tell you the three basic rules that electrons must follow in order to use electron configuration. The first rule is that you must fill the lower levels before you fill the higher ones. You must fill the lower levels before you fill the higher ones. Think of it like building blocks. In order to use electron configuration, you have to build up. You have to state all the electron orbitals before the last one in order to truly explain what kind of electron configuration it is. That's a very basic one. The second level is each orbital. That's how I spell each. Each orbital can only contain two electrons. Each orbital can only contain two electrons, but the s orbital, the p orbital, and the d orbital are different types of orbitals. For instance, your s orbital, the s orbital right here, is one orbital which can contain a maximum of 2 electrons. Your p orbital is in a shape that is able to contain 6. Well, no, let me rephrase that. Your p orbital is in a shape where it's like 3 orbitals in one. So for each orbital, it can contain 2 electrons. But since the p orbital can have 3 orbitals, it can really contain up to 6 electrons. So think of it like the p orbital has multiple orbitals, and it can contain, it has a multiplicity of 3 orbitals, and each one can contain up to a maximum of 2 electrons per orbital. So the p orbital can contain 6 electrons. And finally, your d orbital is much like your p orbital, but instead of having only 3 orbitals, it has 5 orbitals, and each orbital can contain 2 electrons. So that means your d orbital can have a maximum of 10 electrons. So to put it to you simply, your s orbital can contain up to 2 electrons. Your p orbitals can contain up to 6 electrons, and your d orbitals can contain up to 10 electrons. But each orbital can only contain 2. And that's where the third rule comes. You must fill each orbital with 1 electron. You must fill each orbital with with one electron until you use all the orbitals. Then you can go back and place a second electron in the first orbital you used, and then a second electron in the second orbital. So for instance, let's say the p orbitals, let's say you have 4 electrons in the p orbital. So that means that the first thing, you need to put 1 electron in the first orbital of the p orbital, another electron in the second orbital of the p orbital, and then since the p orbitals contain 3 orbitals, you need to put a third one in the third orbital, and only then, when you put 3 electrons in the 3 orbitals, then you can go back and put the 4th one in the first orbital, and that's the maximum pair that the first orbital can have, only 2, according to the second rule. So now you have a rough idea of how these levels and orbitals work. So now I'm going to teach you how to use electron configuration. I will now teach you electron configuration. So the only thing that you really need for electron configuration is your periodic table. So much like how I said before, there are different energy levels that electrons have. You have your first level, which contains your s orbitals, your second level, which contains your s and your p orbitals, and your third energy level, which contains your s, p, and d orbitals, and so on and so forth. Well, the periods on the periodic table are what is represented when you talk about the different energy levels of electrons. So the first energy level is the same thing as the first period on the periodic table. And the same thing applies with the different types of orbitals. The s orbitals are the 1a group and the 2a groups, including helium. That is your s orbital region. Your p orbital group is your 3a, 4a, 5a, 6a, 7a, and 8a groups, excluding helium, which is part of the s group. Those are the elements that are going to be in your p orbitals. And then the transition metals are going to be your d orbitals. So to make things more simple, let's do an easy example. Hydrogen. Hydrogen is the most basic element on the periodic table. The electron configuration is the same. It lies in the first energy level. So the first thing that we're going to want to put is a 1 right there. I don't know if you can see that, but that's a 1. And since hydrogen lies within the S group, you're going to put an S next to it. I'll move this paper over here so it's easier to write. You're going to put an S right there. And since hydrogen contains 1 electron, all you have to do is put 1 electron there. So that is the electron configuration for hydrogen, 1s1. The same thing applies for helium. Helium is in the first energy level, so you're gonna, and it's also within the s orbital group, so it's going to be 1s, but since it contains 2 electrons, 1s2. And since in our rules it's stated each orbital can only contain 2 electrons, you're done with it. That is all that you can do for the electron configuration for helium. Now let's do a harder one, phosphorus. Now, in order to do phosphorus, we have to follow the rules, like in anything. So the first rule states we must fill the lower level s orbitals before you fill the higher ones. So you have to fill them up. So, like I said, 1s2, signifying that you filled the first energy level. 1s2. That is all that you can signify for the first energy level because it only contains s orbitals, which can only have a maximum of 2 electrons. Then you go on to the second energy level. 1s2, 2s2. You have to fill the orbitals in the s orbital groups because you're looking for phosphorus, which is in the p groups. So you need to fill the s groups first. So 1s2, 2s2, and then 2p6, because phosphorus is in the third group.
or in the third energy level, I should say. So you need to fill everything in the second energy level first. So since the p orbitals can have a maximum of 6 electrons because there are 3 orbitals in the p orbitals, then that means that you fill them all up completely. So there are 3 orbitals within the p orbitals, and each one contains 2 pairs of electrons. And that fills up the entire p orbitals. So now we can go on to the third energy level. And since the third energy level also contains the s orbitals, we do 3s2, because the s orbitals only contain 1 orbital, which have a maximum of 2 electrons. And then finally, 3p1, 2, 3, because phosphorus is the third element of the p orbitals of the third level. So we do 3p1, 2, 3. 3p3. So this is the electron configuration for phosphorus. 1s2, 2s2, 2p6, 3s2, 3p3. That is the foundation of how to do electron configuration. So I hope that you have a now basic idea, because this can determine what type of element you're dealing with and the properties of the element. So now let's do a harder one that contains the d orbitals. So let's try to find zinc. So like I said, like the first rule states, you have to fill the lower levels before you fill the higher ones. So for zinc, it's 1s2, 2s2, 2p6, because the p orbitals, since there are 3 of them, I can't say this enough, the reason why it's confusing because people get the second rule confused with the number of electrons. It is true that each orbital can contain 2 electrons, but the p orbitals, the d orbitals, are very unique where they have multiple orbitals in them and they can contain more electrons. So 2p6, because that's the maximum amount of electrons that the p orbitals can hold. And then you go to the third energy level. 1s2, 2s2, 3p6, 3s2, 3s2, 3p6, because you need to fill up the third energy level. And then you finally go to the fourth energy level, 4s2, because you're trying to find zinc. But now we have hit the transition metal groups, which are the d orbitals. So the number one thing you have to know when you're dealing with the d orbitals is that the energy levels of the d orbitals is 1 before the period. So since this is the fourth energy level, the d orbitals are now going to be on the third energy level. So it's 3p6, 4s2, 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3d10. And that is the electron configuration for zinc. So for d orbitals, the energy level is 1 before the period, while s and p are the periods themselves. And that is the electron configuration for zinc. And now just for one more clarification, let's do a very hard one. Let's do iodine, which is 53 on the periodic table. So that means that there are 53 electrons within this element. So, like the first rule states, we have to start from the very beginning. For iodine, it's 1s2, 2s2, 2p6, 3s2, because we're going in a pattern here. We're starting from the upper leftmost and we're moving to the right down. So we're going this way. If we look at it like that way, it's not very hard to figure out where the electron configuration is going to be at. So like I was saying, it's 1s2, 2s2, 2p6, 3s2, 3p6, and then we're going to the fourth energy level, 4s2, and now we're entering the D block. But like I said before, the D block energy level is one before the period. So it's 3d 10. Because the d orbitals, since there's 5 orbitals in the d orbitals, it can contain up to 10 electrons, because each orbital can have 2 electrons, as the second rule states. So 3d10. And now we have filled the entire d orbitals, so now we go back to the fourth energy level of the p's. 4p, 4p, 1, 2, 3, 4, 5, 6. 4p6. And now we have completely filled the fourth energy level, and now we're going to the fifth energy level. So 4p6, 5s2, 5s2, and then like I said, the d orbital, the d energy levels are one before the period, so 5s2, 4d10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I didn't count that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then now we enter the p orbital. So 4d10. And now since we're going back to the p orbitals, we use the period that is given. So now it's 5p6. Or no, not 5p6, I'm sorry. 1, 2, 3, 4, 5. There's iodine, so 5p5. And that is the electron configuration for iodine. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p5. And that is electron configuration.
Today I will be teaching you orbital diagrams. Orbital diagrams are very similar to that of electron configuration. So, much like electron configuration, you're going to state your energy levels. You have your first energy level, your second, your third, your fourth, and so on. So for helium, let's do the orbital diagram for helium. So much like electron configuration, you're going to state your first energy level, and that helium is in the s orbital region, so 1s. But instead of putting the upper script of 2, we're now going to depict it by using a diagram. And we use that and the diagram is going to be a box with an upper arrow and a lower arrow indicating the electrons. So one electron's going up, the other one's going down. That is going to be the electron, the orbital diagram for helium. Now let's do one for chlorine. Chlorine is also very similar. You have to do like the first rule states, you have to use your building blocks. So it's 1s, but instead of doing the upper scripts, we're going to do the arrows. So one arrow is going up, the other arrow is going down. There's your first level right there. Now you do your second level, 2s. One arrow going up, one arrow going down, and now you're in your p regions. But as you know, your p regions have more than just one orbital. It's going to have 3 orbitals. So now we indicate that by writing 3 boxes. And as you know, each orbital can only contain a maximum of 2 electrons. So now we fill these up with the arrows. 1s, 2s, 2p, and now we're on our third energy level, 3s. And since we're on our third energy level, the s orbitals can only contain up to 2 electrons, so we do one box, so there's one orbital, and then with 2 electrons. And now we're on our 3 p's. And as you know, chlorine is 1, 2, 3, 4, 5, the 5th one in the p orbital region. So we still write our 3 boxes for the p orbitals, but we're only going to do 5 electrons. But as the third rule states, since each box represents an orbital, we have to fill each orbital up with 1 electron before we pair them up. So each one first gets 1 electron. And then we go back and pair them up. So now it's 1, 2, 3, 4, 5. This is the orbital diagram for chlorine. Now let's do one more to wrap this up. Let's do iron. Iron is 1s. The diagram. 2s, the diagram, because you still have to do the building blocks. 2p, but since your p's are 3 orbitals, you get to write 3 boxes.
and you fill them up with the arrows or the electrons. 1s, 2s, 2p, 3s, 3p, 4s, because now we're in our fourth energy level, 4s. But now since we're in our D region, we are going to go back to one before this period. So we're going to go 3D, because as you know, the energy level for D is one before our previous level, or our current level. But since D now has 5 orbitals, we're going to do 5 boxes. And as you know, the third rule states each orbital has to contain 1 electron before we can pair them up. So since iron is 1, 2, 3, 4, 5, 6, each one of these are going to first get 5. So 1, 2, 3, 4, 5. And then we go back to the first one, 6. So this right here is the orbital diagram for iron. So now this is the lesson of electron configuration and orbital diagrams. Thank you for listening.